today, 12.3, we are going to be able to model quadratic functions and make that ax squared plus bx plus c. We're going to be able to make all that based off given information that we know and points that my parabola goes through. So this was when I was trying to model the other day, poorly trying to toss the ball back to Grant or whoever at the back table. And we know that every parabola has what characteristics? What are some things that we know about it? Everyone's going to have what things?
A minimum and a maximum.
Well, a minimum or a maximum point. So a vertex really is what we're going to say. Every parabola has a vertex. What also is at that vertex, Robert?
At the vertex?
At the vertex. What else happens at that vertex?
Oh, is it
A line of symmetry occurs at the vertex. Raider? Yeah, so that's our vertex. Here it's the apex because it's the topmost point. Yeah.
like if it's a ball?
Yeah, so there's a point where like our up-down movement stops and then it changes direction. So if I'm going down, it then goes up, vice versa. And because this line of symmetry happens, we know that assuming we start at the same height on the left side, this distance would be the same as this distance. It's kind of a poor drawing. And the same as any points along here. So if I put a point there, I can find a matching point here. If I put a point there, I can find a matching point there. So this is only on your notes to remind you of those things. We're going to breeze right past this because I went ahead and put the answer there if you're wondering about that. But when we go to write the equation, we want to look at what it is that we know. So we have this situation. A parabola contains these 3 points that we see. What is the equation of this parabola in standard form? Substitute in x, y for the values and write a system of equations that can then be solved. So if you remember back to Math 1, one of the things that we were doing a lot of is systems of equation and combining the systems of equations in order to isolate out a variable or isolate out a couple of variables to get us to where we want to be. So we have these 3 points, 0, 0, -1, -2, and 1, 6. We know that every parabola is going to be the
form y equals a times x squared plus b times x plus c. Then solve the system to get a, b, and c.
What's weird is that's going to be on the video then also, unless I can figure out how to mute him. Maybe I'll just mute the computer and hope that that works.
Wait a minute, you're taking video still?
Yeah. Even if people aren't here, I want to record that video. So, easiest point to start with is 0, 0. If I plug in 0 for my x value, and I plug in 0 for my y value, now remember, this will sometimes be presented to you as
this equation
f of
simplifies
x,
to
a
0
function
equals c.
relative to x, but that's really a fancy way of saying y, because that's the value that it spits out, that's your output. So if I plug in 0, 0 for all those points, I see, okay, c equals 0. That's nice. I now know part of my ax squared plus bx plus c, I can now say, well, c, okay, that'll be 0. I move on and plug in another one of my points.
Now
so
use the point -1, -2.
Negative 1 for every x value. You guys want to be writing this down, by the way, because it's not solved out in your notes. Plug in -2 for the y value. And then for the moment, we're just going to leave it with what we find. So we get that -2 equals 1a, which is really just a.
This equation simplifies to -2 equals a minus b plus c.
But we just leave it as it is for now.
And finally, use the point 1, 6.
I then use 1, 6 and do the exact same process. Plug in a 1 for every x. Plug in a 6 for the y. The 1 for my x makes my life easy. And I get 6 equals 1a plus b plus c. Yeah, it's stopping right here. I'm leaving it right
This equation simplifies to 6 equals a plus b plus c.
I got your feedback on one of your homeworks that you turned in now, Emily, and as well as feedback from Greg. And that's one of the reasons why we have transitioned to a lot of your homeworks will be the K forms, because now Pearson gets a little crazy with how many questions are on some of them.
Thank you
So appreciate the feedback. As long as it's presented in a respectful manner, I will internalize it and change to adapt. You wrote on one of the things like, this was, what did you write? I thought it was fun. I just left a hand back, but I was going to go later. Mr. Hudson, this was a lot of tedious work. 58 questions is a lot of work for one homework paper. But a lot of those are really fast problems. But you know, I said duly noted. I have changed, and that's why we're doing Form Ks. So does this make sense? Do we understand plugging in the x and y values and just getting my equations based off that? The important equations that we're going to look at here are the ones that actually use a, b, c, and some values. The 0 equals c, not very important. Any questions here? Are we good? Not really questions or not really good?
Not really question.
Okay. So then, if you remember back to Math 1, when we have a system of equations, how do I find the solution? How? I've got multiple equations here. How do I solve when I have multiple equations? In a way, yes. Jacob?
Well, you can substitute.
Yeah, we can isolate one of them and then substitute. Leon?
We could just add both of the equations.
We could combine the equations through addition or subtraction. So, I now want to combine those bottom two equations. Or
Since
those,
c equals
equations that
0,
involve
the remaining
equations.
system has two variables.
Now, because I know that c equals 0, I can, in both of these equations, replace c with 0. So what I really have is a minus b equals -2, and a plus b equals 6. So these are really the equations that we're going to use as we move on. Because my c was 0, all I did was really get rid of the c. Anyone know that we should add or subtract these? We can do either. If we subtract, we'll get rid of the a's. If we add, we'll get rid of the b's. So we can do either. I like to add them because it makes life a little easier. When I add them
Solve this
together,
system by elimination.
my a adds with my a, I get 2a. My negative b and my b combine to cancel each other out. And my negative
Add the
2
two
plus
equations
6
to
will
eliminate
give me
b.
a positive 4. So now I get 2a equals 4. Wonder what a could be. That then tells me a must equal
8.
Now
must
simplify.
equal 2. Then what do I want to do with that a?
Plug it in.
Plug it in. Which one?
So a
Doesn't
equals
matter.
2.
Either of them. Whichever one you think is easier. Yeah, which the bottom one here looks easier. So you plug it back and we say, okay, 2 plus something equals 6. Wonder what it could be.
8.
Get it? B.
It must be the square root of 6. Is it 4?
It is 4. Thank you, Mr. Laws. We find out that b is
Now
4,
substitute
but then
the value
again,
of a
we still
into
have to
one of
put
the
all this back
equations.
into the ax squared plus bx plus c form.
Which question are we on?
We're still on 1. Just the first
And
one.
simplify.
Wow. It's all part of one. Someone tells me it's going to take forever.
That's why I'm trying to get through this and give you guys time.
So b equals 4. Given
My
points.
equation becomes, come on, Smart Ink. Y equals 2x squared plus 4x plus 0, so we don't need to put the plus 0. If this makes sense, go ahead and move on and try that. Got it.
Totally made sense.
If you have a 0, 0 point, I always advise starting with that because it's easy.
0, 0 point. You can just derive that c equals 0. Yeah. Because
Yeah, I'm gonna show the work.
So it doesn't have any y intercept. Yeah. So you can just immediately. Yeah. See, we have this mental connection. You already knew that. Okay, maybe that's true. Just maybe.
So we know all of this is working in y equals ax squared plus bx plus c. So c must equal 0.
Wait. Oh, I thought you had finished the question.
C must equal 0. That's what I find from using my first point. My next point I will use blue for. So I'm going to use 1, -2. And plug in. -2 equals a plus b plus c. You could go ahead and replace the c with 0 if you want, or wait. When I plug in my third point, anybody have any questions for what I've done up to this point? Those two highlighted equations are the equations that I'm going to use as we move forward.
We need a door right there.
We really do. I thought about getting a sound deadening curtain, but I don't think it'll help much. Any questions? We're good here?
Sounded like something really special, like a sound deadening.
You can get really, really like nice ones that are super thick fabric that are designed to catch the sound. It's like the sound foam that they put in like certain rooms. Moving forward then, I can replace both those c's with zeros and tell myself that the two equations we'll use are, I like to flip it around so that my variable values are on the left. I have a plus b. Were you trying to give them to me?
Yeah.
Okay, what's the second one turn into then?
A minus b equals -4.
So then I ask myself, how can I combine these to make things easier? Okay.
I added them again.
We can add them. So I'm going to clear this. A plus b equals -2. A minus b equals -4. Because I'm adding, I just leave everything how it is and combine. 2a must equal -6. So a has to be -3.
Is this because C equals 0 or what?
Yeah, so right here, I went ahead and changed my equations so that the c was 0. Just made it disappear, and I flipped them around because we just like it better that way, or at least I do. Ben?
I plugged it in and then we got
Which did you plug into the top or the bottom? Yeah, either one will work.
Either one's easy.
I actually think the bottom one would be easier, but it doesn't matter. Choose either the top or the bottom. So if we plug it in the top, we get -3 plus something equals -2. What would b have to be? 1. Then I'm able to write out my whole equation as y or f of x equals -3x squared plus 1x plus 0, or we don't have to write the plus 0. Questions? Yeah. No, it's you don't have to. Sometimes it's nice to make sure, like, then you're showing, yes, I found what b was, and it was 1. Otherwise, sometimes people might think you forgot about it, but you don't have to put it there. We assume that it's there. Which, yes, assuming is very dangerous, but whenever we have a variable, we know there's at least a coefficient of 1. All right, flip to the back. We're going to do the same thing.
In this problem, you'll use a quadratic model. A player throws a basketball toward the hoop. The basketball follows a parabolic path through the points shown. If the center of the hoop is at the point 1210, will the ball pass through the hoop?
Oh, yeah, if the points are symmetric from each other. So you mean, yeah, so Well,
down already.
are you sure?
It's gonna hit
Because
and then bounce off.
are you talking about the got it or the one on the back?
The one in the back.
Oh, okay. I thought you were back talking about the got it because that won't really work right with the got it from the
No,
front.
I'm talking about the basketball one.
So what do you mean by you can just?
If you look at where it goes from the first point to the second point,
Yep.
it goes up 2 and to the right 2.
Yep.
And then if you look how it goes from the other point, you can see that there's a max value there because it stays at the same height.
Yeah. There must be some vertex in between here, which also means that there's the axis of symmetry halfway between.
And then that means that the next point would also be down to right 2.
Yeah.
Point, and then that puts you right on the coordinates of the basketball.
Yeah. So if we see it, so Seth's saying I can just look at this, and because I see some looks of confusion, he said I can look at this and say because these values share the same y, they're symmetric to each other. So the line of symmetry must be halfway between them, and so would the vertex, and it would have to be halfway between 4 and 10, so that distance is 6. We go 3 more over. It's going to have an x value of 7. We don't necessarily know what the y value is. We could figure it out, but the problem is what you're looking at is slope, like down to, up to, right to, and all that stuff. That doesn't stay consistent because it's parabolic. So,
You already have the
Well, no,
point
since
that's symmetric.
yeah,
You already have the point that's symmetric to the hoop itself.
Right.
since they were
so since the question is directly asking, if the center of the hoop is 12-10, will the ball pass through?
Nope.
Well, if I go over 2 to 12, like this had gone over 2 to get to 4, and then it went up 2, so I would have to go down 2. That next point, 12, 10.
Guess what the hoop is?
Yeah, it would. Just by visual reference, it would. But if we want to actually solve this out, and not just use the visual representation.
Well, the point's on the hoop, but it could have just hit rim first.
Well, it says the
The guy does not
Yeah,
look
the
like
center of the hoop, so that's kind of, it's, yeah. We would assume that things worked out nicely.
Step
We want
1.
them to work out nicely.
Find the quadratic model.
So,
Substitute x and y values into the
here's
standard
difficult
form
thing.
of a
We don't
quadratic
have 0,
equation.
0 here.
The
So
result
we're
is
gonna
a
end
system
up
of
with
3 linear equations.
that are actually useful. So we need to plug in our xy values. We're going to start with
Use the
10.
point to 10.
Plug in the 2 for every x and set your 10 there in your y space. So we're going to end up with 4x squared
Now use the
plus
point
2b
10, 12.
plus c equals 10. Questions on plugging in the 210?
Hold up.
Because 2
And
gets
use the point
squared,
for
they're
12.
moving on. So, yeah, that's why it's plugging in for these x values. 4x squared because, okay, so here, sorry, I'm getting ahead of myself. Should not have said it how I said it, so I apologize. It's 4a plus 2b plus c. We're not in the ax squared plus b, yeah. So I simplify these equations. I really want to rewrite them in their better form. So here's the system that we end up with my variable values on the left side and my constant values on the right side. Ask it. What is it? Are you good?
I think so.
You think so? Because my 2 squared gave me the 4, my 10 squared gave me the 100, and my 4 squared gave me the 16. That's why I got my coefficients right.
Yeah.
Don't sit in the back. We got some prime seats up front. Any other questions aside from I can't see?
That's a
That's a statement of fact. That's not.
I know. I can't see.
No, can I
Robert?
see?
Ah, so that's a really good question. Jacob?
Wait, is he asking how you would
Yeah, so when we look at how I'm going to simplify, what am I going to do to combine these? we can really choose whichever 2 we want to. Which 2 would you choose?
Use one of the methods from Chapter 3 to solve the system.
Yeah, we're going to have to do
Which
it
method
twice.
should you use to solve the system?
After you get that, you get two, because the C's simplify out.
Cancel out, yeah.
Yeah, cancel out, and then you get two equations that just have A.
So, when we're thinking about which method would I use here, and you guys might need an extra sheet of paper because I don't leave a ton of space on the notes. I try to fit them onto one page.
Oh my ears.
As Jacob said, I can combine 2 of these. Now, what I would do when I look at this, I would take the bottom equation and subtract away the top equation. Just because those numbers work easily with each other. So if I try to set that up, it'd be the 16a plus the 4b plus c equals 12. I will be taking away from it, so I'm going to do that in red, minus the quantities 4a, 2b, c, and 10. When I combine those, I get 12a plus 2b equals 2. Now I've got an equation without a c that I could work with. So I want to do that again with 2 different equations. Might as well use the second and the third.
I was going first and second.
You were going first and second. So you're going to go second minus the first.
Yeah.
Yeah, you can do either the second minus the first or the second minus the third. Either way, I mean, it's just going to change how you perform the rest of it. So if we go,
Isn't it easier to do the first and second?
easier is relative. It's the same process either way. So it's just whatever you want to do. If I was just going to do this minus that because how it's set up right now, I can just do this and see it. So 100 minus 16 will give me 84a. 10 minus 4 will give me 6b. And the c minus the c cancels out. And that equals just 0.
Oh.
Yeah.
And then you use the equation you just got, multiply the entire equation by 3. That way you have 6b.
I could, but there's another way that I could approach this. Because there's no c here and there's no constant value, I could now use replacement or substitution, whichever way you call it. Because I can say 84a, actually I'm going to change it the other way. I could say 6b equals a negative 84a. If I divide both sides by 6, I'll get b by itself. Negative 84 divided by 6 would be 10 and another 24, so 14, I think. Yep, but negative. So b is a negative 14a. I could plug that b in to my original equation up there to solve for the a value. You guys have a lot of options. That you don't have to take this way. You could do what Leon said and multiply one of them. So if I slow down what Leon was saying, he said I can take the other equation. Were you going to try to cancel out the b's?
The equation I was going to multiply by 3. Yeah.
To cancel out the b's, right? So what Leon wanted to do, because I heard a couple people say slow down, is he said, well, if I have 6b here and a 2b up here, I can make the b's cancel if I triple that whole equation. So we could triple every term in that equation and then subtract the 2 equations. I like substitution. I don't know why. It's just how my brain works. Whichever way you prefer, take that method. So I'm going to substitute in. So I'm going to say 12a plus 2 times negative 14a equals the 2. I'm subbing in the b that I found into the previous equation. I cannot sub it into my original equation because that'll just make me work in circles. I get 12a minus 28a equals 2. I can perform that subtraction. Get a negative 16a equals 2. Which then tells me that a, negative 1/8, and then I can take that a and plug it back into my b. So that it's really clearly shown out in your notes on Schoology, I'm going to take a second and capture some of their part of the solution.
Each C term has E equals 1 and 7500.
So they don't even actually show our methods. Sorry, they jumped right to the conclusion.
An equation of the parabola is
So
y
A was
equals negative
1/8,
125
so did they.
thousandths times
When we
x
plug it in
squared
for our B,
plus 1 and
we get that B
75
is
hundredths times x
1.75.
plus 7.
And I can use both of those and any of the other equations to plug in and solve for C, and C gets 7. Please, are there questions? I really want to know if this is making sense or not. We're using those skills back from Math 1, where we have systems of equations that we're trying to solve. 7, and we could plug in the a and the b to any of our equations to solve it. I would choose the first equation just for ease of multiplication. Some people, actually the third equation might be really good because 16 times 1/8 will make a whole number. The second equation could be nice because the 100 will move my decimal, but any of them will work. My final equation that we get for the parabola is this. We're still not done.
Yeah, what do you do with it from there?
All we want to know is 1210 in the path of the parabola? So now that I've found the equation of the parabola, if 1210 is in the path of the parabola, Seth?
Then shouldn't y equal when we substitute 10 in for y and 12 in for the x's? It should
Yep.
equal.
Sub in 12 for your x values here, and sub in 10 for your y values there. Uh-oh, I hear Mrs. Cullinan talking about interest. So we sub it in.
Is on a parabola.
Come on.
To see if the plane
And if it's on the parabola, it'll be true. It will equal. If it doesn't equal, it's not on the parabola, and it's not a point, not a solution. Since 10 does equal 10, we know this is true. Questions, comments, concerns?
So we had to do all that
To get an answer.
for, yeah.
Yes, but it won't always. You won't always have the picture. It won't always work out that nice. So
That'll be awesome. But
huh? You probably can. You're gonna have. I mean, it's been snowing all day.
It's really compact too.
That's the best.
I was like walking through this morning and it was like sticking to my shoe, so I picked it up and it's
So we are asking.
Yes?
What we want to know is, will the ball go over this wall? So we don't want that point to be on our parabola. We want our parabola to go over that point.
Wait, don't you mean under?
The top of the wall is at 5'6". Will the ball go over the wall? So if we envision, here's a wall. We're throwing a ball in a parabola. We want to see, will it clear the wall? Leon?
It's already at 3.6.
Okay.
How tall is the
we don't
wall?
know when it will go down. So that could be there.
Never mind.
So I agree, it is already at 3'6". So if this wall is at 5'6", my ball is already that high, but it's not far enough over yet. So it might keep going upward, or that might be the maximum point. That might be the vertex, and then it'll hit the wall. Or it might keep going upward, but still not go far enough, and it might start to go down before we get to the wall. So we have to figure out the parabola. We have to figure out the equation.
Because 5 is
So, let's solve it. 1, 3 for x, y, plug them in. So we know we're in the form ax squared plus bx plus c equals y. I'm just going to go ahead and work like this. I'm going to leave my y values on the right side. So, a times 1 squared plus b times 1 plus c will equal 3, which is really 1a. So I can just say a plus 1b plus a c equals 3. My next point I'm going to show in green. 2, 5.
It's not going to make it.
So, a times 2 squared. If you're choosing not to do this right now, you're choosing not to practice these skills and get better. 4a plus 2b plus c equals 5. And my third equation, using 3, 6. A times 3 squared plus b times 3 plus c equals 6. Gives me 9a squared. There's nowhere great to write this. Or sorry, 9a, my apologies. Plus 3b plus c equals 6. I will use any two of these to combine with each other. 1 and 2 have the lower coefficients, so that will be the easier route. Whoa.
Well, 1 and 2 will make it really easy. If you subtract, if you subtract them and then multiply by 3.
So you're going to take equation 2 minus equation 1?
Oh, no, equation 1.
Right.
Yeah. Yeah.
I'd rather do equation 2 minus equation 1 so I have positive coefficients still.
That's,
So I'm going to say 4a plus 2b plus c equal to 5 minus everything inside a plus b plus c equals 3. So this becomes, what?
Never mind. Found it.
3a plus b plus 0 equals 2.
Oh, you're doing 2 minus 1.
So really, 3a plus b equals 2.
And then you can find C using that.
What do you mean?
Because you can multiply it by 3, and then you would get 9a
Ah,
plus 3b.
so if I want to combine it with my third equation up there, I'm going to start with 9a plus 3b plus c equals 6. I will then take this equation over here, multiply the whole thing by 3. That gives me 9a plus 3b equals 6, which works out very nice, because when I go to subtract that away, everything cancels except for the c, and that tells me that c equals 0. Yeah. Okay.
I don't know what you did there, but
We are not going to do quadratic regression today. If you have a TI-83 or any sort of graphing calculator, please bring it to class with you tomorrow. I will have some available, and we may need to work in partners. But tomorrow we'll finish this lesson, take any other questions. I'm going to pass out your homework before you get out of here. But I don't want to work any quicker on this material than what you guys can understand it. So I appreciate when Emily says, hold up, I just need a minute. Like, you guys slowing me down is great. I've learned this and taught it now multiple times. So my speed in my head is going to be faster than what you guys are able to do. So please communicate with me on this stuff. Once I have c equal to 0, Emily, do you mind if I start stepping forward? I can plug that in anywhere that it might be useful. Or I can combine two of my other equations to find out my a or my b. Anyone have a suggestion? What they think I should do here? Emily? Equations 1 and 3. So now that I know that my C's are 0, are you going to say 3 minus 1, or what are you going to do there? So like Leon keeps referring back to, remember, we can multiply any equation by anything we want. But I agree that we can use equations 1 and 3 or equations 2 and 3. Now that I know that C is 0, I just have to make either my A's match or my B's match. So do you want to use 1 and 3? I mean, we can. Do you want to use 2 and 3? 2 and 3? Okay. So I'm going to start with equation 2, but I'm going to subtract away double my equation 1. This is tough because I'm going to capture this, and those are going to go away, so hopefully you have those 3 equations written down on your paper. I don't, so you're going to have to help me. So we have A plus B plus C equals 3. I take that whole equation and multiply it by what? How much? 2. So then my B's cancel out. So really I get 2A plus 2B. C is 0, so forget about it. Equals 6. That can now be subtracted away from what my second equation was. Was it 4A? Plus 2B. C is 0, so we don't need to worry about it now. Equals 5. I subtract away everything from over here. 2A, 2B, and 6. However you write the subtraction, I like to put it like this. So I know I'm just doing subtraction from top to bottom. I don't like to distribute the negative symbol. If you want to, you can. So we get 2A, my B's cancel, equals negative 1. When I do the division, A equals negative 1/2. I now know my A and my C, so I can plug those back into my first equation and find out my B. So remember, C was 0. I can take both those back into, actually I can probably stay on this screen. So I use my A plus B plus C, but A is now negative 1/2. B I don't know. C is 0. I could just not write it if I want. It's going to equal 3. What would B have to be in order for negative 1/2 plus B to be 3? Right? 3.5 or 3.5. I now have my A, my B, and my C. So my quadratic formula becomes negative 1/2 x squared plus 3.5x plus 0 equals y. We're still not done.
Now I gotta figure out.
You have to substitute stuff.
But if we're trying to figure out if the ball goes over the wall, how do I do this? What? So do I want to sub in the whole 0.56? Steph? Yeah. We know the wall is at 5. I don't care how tall the wall is. I care what height my ball will be at. So sub in your x equaling 5 to the parabola and find out what does your y equal. If it's more than 6, your ball cleared the wall. If it is 6, I don't know, it skims the top of the wall or hits the top of the wall. And if it's less than 6, we know it's nowhere close to clearing it. So if I get rid of these, yeah, I did capture that. Got nervous for a second. Come on. Yeah. It depends on how much higher than the wall we are. So if we're a lot higher, we don't really have to worry about it. If we're barely higher, then yeah, we'd want to think about that. Negative 1/2 times 5 squared plus 3.5 times 5 plus 0 equals y. This is going to be half of, or negative half of 25. plus 17.5, I believe, plus 0 equals y. This is a negative 12.5 plus 17.5 equals y, which means that my y equals. Does it clear the wall?
No.
No.
It's all over.
It hits the wall.
I'm
Did you say it's all over now?
That's reasons.
Does up to this point make sense? Jacob?
Yeah, but you still have to find what point it'll hit the wall.
It'll hit it on a downward
You
trajectory.
still have to.
What do you mean what point it'll hit the wall? That's
If not, will it hit the wall?
so I plugged in my x equaling 5, so my ball's at the wall now.
It's
So
hitting on
that's
a
the y
downward
value
Oh, my
at
bad.
the wall. So it will hit the wall 1 foot down from the top, is what that tells me.
Whoever's throwing that
It's
wall
almost
is
not.
not. That's like.
You try whatever you can. There's not much here using the graphing calculator. You might need to skip 10 and 15 until tomorrow, but there are only 17 problems on this. But we only did 4 problems.
So wait a minute.
Oh, is it 17 of these or 17?
No, you might need to wait to do those because the quadratic progressions, when they give you a table, you can just plug the table into your calculator and it does the math for you. Try to do as much of this as you can, and we will go over this tomorrow. You guys might as well just head on out to lunch. You are only a minute early. Grant, yeah, right? Sweet.
And my binders. Lunch today.